Okay, so at this point, as far as taking derivatives go, we know we have the limit definition for derivatives, but we also have the power rule and the product rule as far as maybe shortcuts to find different derivatives that we want. But, well, the question becomes, again, ultimately, what if I have even more complex functions that I want to take the derivative of? As an example, suppose I have f of x equals, well, maybe even really simple, 1 over x. Now, how exactly would I find the derivative of 1 over x? That's not even a really complex function. It's a rational function, but how do I find its derivative? Well, I can actually use my rules for exponents. 1 over x is the same as x to the negative 1. Now, that I can just use the power rule for. So then what would f prime of x be? Let's see, I'd bring down the power, so negative 1. Then I would lower the power by 1. And negative 1 minus 1 is negative 2. And then my derivative would be negative 1 over x squared. And I could certainly throw a constant in there if I wanted to make this a little bit more complex. And then the constant I could just pull out to the front and stick it up there at the end. So maybe this is not too hard, but well, what if I have something like f of x equals 3x plus 1 over x plus 2? How would I take the derivative of that? Well, here I can't just bring this to the top. I guess in theory, I could rewrite this as 3x plus 1 times x plus 2 to the negative 1. We might actually do that later on. Not today, but eventually maybe. But, well, I can't FOIL those out because that's to the first power, that's to the negative first power. It's in the denominator. So those can't be FOILed out. I could maybe try to do a product rule on them, but how in the world does a product rule work with that? Or even that? So I'm kind of out of luck. And again, this is maybe slightly more complex than that. But as far as rational functions go, that's really, really straightforward and simple. So what do I do for rational functions like this? Thankfully, there is another rule. It's called the quotient rule. And now, the proof of the quotient rule, the actual derivation of it, is not incredibly complex. It's in your book. It's actually really similar to the derivation of the product rule. If you remember the derivation for the product rule, I arbitrarily added and subtracted something, which then made it algebraically solvable. You do the same thing here. What you have to add and subtract is a little bit more complex, but the principle is the same. To save time, since we already did the one for the product rule, I'm not going to do the one for the quotient rule. But you can look in your book and kind of work through it. And if you have any questions, just email me, call, text, whatever. And then maybe I'll formally do another video just working through the proof of it. I just don't want to spend the time here now because we actually want to do this. And the way it works is, suppose I have f divided by g of x, a quotient. Here, 1 divided by x, or 3x plus 1 divided by x plus 2. That's f, that's g. That's f, that's g. You all understand how this works. If I have that, then f divided by g prime of x, the derivative, is equal to g of x, f prime of x, minus f of x, g prime of x, all over g of x squared. And again, you can actually rearrange these. You can't rearrange the difference, but sometimes people will write f prime of x, g of x, minus f of x, g prime of x, or whatnot. This is the way it was written out when I learned it and I had to memorize it. Just like the product rule, I can only do it one way or I get confused. Quotient rule. Bottom, g of x, times the derivative of the top, f prime of x, minus top, derivative of bottom, all over the original bottom squared. And as when I was a student, I would literally, when I was studying, just repeat that over and over. Bottom derivative top minus top derivative bottom all over bottom squared. Bottom derivative top minus top derivative bottom all over bottom squared. Just like the product rule. It was the only way I could remember them. But it looks complex, yes, but ultimately it just means I need to take a few derivatives of simple polynomial functions and then plug it all in. So for this, and keep in mind, this is f of x, which is a rational function. The quotient rule, you just separate them in your head. Top and bottom, f and g, call them whatever you want. So, f prime of x. Well, maybe we'll actually start here. Because, well, since I'm not formally doing the proof of this, I want to make sure this rule actually works like it should. I know the derivative of this rational function. So let's apply the rule, plug it into the rule to make sure I get what I should. So according to the rule, for 1 over x, the derivative should be the bottom, which is x, times the derivative of the top. The derivative of 1, it's a constant, so that's 0, minus the top, which is 1, times the derivative of the bottom. The derivative of x, well, again, we did this last time, but just to reiterate, x is x to the 1, power rule. Bring down the 1, lower the power by 1. X to the 0 is 1, so I just get 1. Put another way, that's a linear function. The derivative is the slope. The slope of that is 1, the coefficient of x. So that's 1 all over the bottom x squared. X times 0 is 0. Negative 1 times 1 is negative 1. All over x squared. And I get exactly what I should. Which means this rule seems to work. Now, we can apply it to more complex functions. So, we're going to use this. What's my f prime of x? Well, let's see. According to the rule, it's the bottom, make sure we use parentheses, x plus 2, times the derivative of the top. The derivative of 3x plus 1. The derivative of 3x, that's linear, so it's 3. The derivative of 1 is constant, so it's 0. So bottom, the derivative of the top is just 3, the slope, minus the top, 3x plus 1, times the derivative of the bottom. The derivative of x plus 2, that's linear, it's the slope, 1. All over the bottom, which is x plus 2, squared. Now just simplify the whole thing out. Distribute the 3 in the beginning. So 3x plus 6 minus, that's just 1, so just distribute the negative, minus 3x minus 1 all over x plus 2 squared. And then I suppose we can simplify this a little bit more. 3x minus 3x is 0. 6 minus 1 is 5 all over x plus 2 squared. And now I have my derivative. All things being equal, the rule is pretty straightforward as long as you remember it. Bottom derivative of top minus top derivative of bottom all over bottom squared. So, since we have time left, maybe we'll do a more involved one. Ultimately, all of you have done math for a while now. You understand how this works. You have a product rule, you have a quotient rule, you have a power rule. Now your problems start tying all of those things together. We already used the power rule while solving out with the quotient rule there. So suppose I have f of x equals 2x plus 3 times x minus 4 over 3x squared plus 1. Now I want to find f prime of x. And here is where it's entirely up to you how you solve this. Meaning, for these, I'm not going to tell you solve the derivative in this way. I'm just going to say find the derivative. You can say, that's a rational function, quotient rule, and done. You can say, oh, okay, I'm going to FOIL out the top really quickly. That would be 2x squared minus 8x plus 3x, so that's minus 5x. 3 times negative 4 is negative 12. All over 3x squared plus 1. And you can say, okay, I'm going to do the quotient rule on this, which is fine. Or you can say, I'm going to do the quotient rule on this, and I might have to use the product rule, because those are multiplied together. I'm going to do it that way just so we can see it written out that way. And then if we have time, I'll run it through the quotient rule this way to check our answer. If not, you can do it on your own time. But supposing I wanted to do it just using that without foiling things out first. We would say quotient rule. It's the bottom, 3x squared plus 1, times the derivative of the top. The derivative of the top, that's a product. So product rule. The first, 2x plus 3, times the derivative of the second. The derivative of x minus 4 is 1, plus the second, x minus 4, times the derivative of the first. The derivative of 2x plus 3, that's linear, so it's a coefficient 2. Now we have bottom, derivative of top, which is a product rule, minus top, and here I'm going to run out of room, so I'm going to have to go down here to a second line, minus the top, which is 2x plus 3 times x minus 4 times the derivative of the bottom. That's a power rule. Bring down the 2. 2 times 3 is 6. So that will be 6x. The derivative of 1 is 0. All of this is over the bottom, 3x squared plus 1 squared. So again, keep in mind, this is all one big numerator. Bottom, the derivative of the top by way of the product rule, minus top, times the derivative of the bottom, all over the bottom squared. If you then chose, you could distribute here, combine like terms, FOIL with that, FOIL here, distribute there, combine like terms, distribute your negative, combine all the like terms, whatever on the top, and then go from there. That is completely fine, and I'm fine with you doing that. I'm actually fine with you for now leaving it like this. The alternative, if you FOILed it out first, would be to say, okay, now I can do the quotient rule on that. So it'll be the bottom, 3x squared plus 1, times the derivative of the top. Here, go term by term. 2x squared, bring down the 2, so that becomes 4x, lower the power by 1, so it's to the first, minus, that's linear, so it's just the coefficient, that's a constant, so it's 0. Bottom, derivative of top, minus top, times the derivative of the bottom. And we already said the derivative of 3x squared plus 1 is 6x. All over the bottom, 3x squared plus 1 squared. Bottom, derivative of top, minus top, derivative of bottom, all over bottom squared. And again, I don't care how you find your derivatives. You need to know the rules well enough, power rule, product rule, quotient rule, any other rules we go through, to be able to say, oh, that's a quotient with the product rule, I'll find the derivative that way. Oh, that's a product that I can FOIL out. Now this is another easier quotient rule. It doesn't matter to me as long as you can actually apply the rules correctly, do the algebra correct, and then get the derivative correct. So now you have 3 rules, power rule, product rule, quotient rule, and we're going to go through a few more rules because let's face it, there's a lot more functions we want to find derivatives of. If nothing else, we haven't even talked about trig functions and exponential and logarithmic functions yet, and we have to get through all of those as well.